Let's look at number 8. So if iron is mined from the earth as iron ore, common ores include Fe2O3, hematite, Fe3O4, magnetite, and Fe2O3, which is siterate. So calculate the mass percent composition of iron for the first one of these iron ores, calculate the mass percent composition for iron for the second one of these iron ores, and calculate the mass percentage or mass percent composition for the iron for the third one of these iron ores, which ore has the highest iron content. So we want to figure out basically mass percent composition. So let me break this down to A. So A here is Fe2O3. So we have Fe2O3. So this is hematite for our first mass composition. In all of these problems here for mass percent compositions, every time you see a percent here, we want to assume something. In terms of our assumption, we're going to assume our mass here, and we're going to assume that it's going to be 100 grams. And the reason why we assume 100 grams is because it's easier for us to work out the percent of those guys here. So assume we have 100 grams of Fe2O3. So if we assume our mass here, what we can do is actually calculate the moles, right? Because again, we have moles. Moles is equal to mass over molar mass. So we have 100 grams over the molar mass of Fe2O3. So let me find that out for you. And let's bring up our periodic table now, because we're going to need to know that. So Fe2O3, so I have Fe, which is here, so 55.845. Multiplied by 2, because we have 2 irons. So we have 2 times 55.845 plus 3 oxygens, which is 3 times, again, oxygen is here, so it's 15.999. And then we can calculate that, use your calculator. So we have 100 divided by 2 times 55.845 plus 3 times 15.999. We're going to get a value of 0.626. So let's check our answer here, which is good. So they have also 0.626. Maybe I'll add more decimals here. 0.6623 moles. And then what we can do now is we can look at our mole to mole ratio, right? We have 0.62623 of this entire compound. However, how many do we have of specifically iron, right? We care about the iron. And again, what we can do is we can actually write out our chemical formula to figure out the mole ratio, right? So we have Fe2O3, so we're going to have Fe3 plus O2, right? And then we can balance this area out by writing a 2 for iron, and you can think of this as 3 over 2 for this guy, or you can think of it as 3 here to give us 6, and this one would give us 2, and this one would give us 4. But again, we don't really care about balancing here. We care about simply just the iron coefficient here, because it's not asking us for oxygen. So we can say it's a 1-to-2 ratio here. So we're gonna have to multiply this mole ratio by 2 to give us our moles of iron. So this is Fe2O3. So we're going to take that, we're going to multiply it by 2. Multiply that by 2 moles of Fe divided by 1 mole O3, sorry. Then these guys are going to cancel out. So I'm going to get my moles of Fe is going to be 0.62623 multiplied by 2, which is 1.25246. Now what we can do is we can convert this back into our mass and then calculate the mass percentage, right? So we have moles here, want to go back to mass. So if we want to figure that out, we have moles equals mass over molar mass, which means mass is equal to moles times molar mass. So this is going to be equal to 1.25246 moles multiplied by the molar mass of iron, which is what we wrote about, which is what we wrote here, right? 55.845. Moles are going to cancel out, and we're going to be left with grams. So multiply that by 55.845, and we get a value of 69.94. And then what we can do here is we can simply now calculate the mass percent, right? So mass percentage of iron is simply just the mass of this divided by the mass of 100 grams here. So we have 100 grams of Fe2O3. So we can say mass percentage is equal to mass of Fe divided by the mass of Fe2O3. So 69.94 divided by 100 grams. This is going to be equal to 69.94%. And this is our percentage for our first composition. And what we have to do is we have to repeat these steps for the second and third options as well. So this one was the first one, which is actually our correct answer. I think they're off by 0.1, but that might be a rounding error on their part, but that's okay. What I can do is I can actually do the other two as well, just to check their answers. So I have 69.94, which is our first answer, which is good. So Fe2O3 has a 69.94% of Fe, and then I'm going to do the other two, and I'll do this a little bit quicker because it's exactly the same process. So we have Fe3O4 this time, which means we have Fe plus O2, and we're going to have, let's see, we're going to have 3 irons and 2 oxygens here, and we don't really care about the charges that much here, but you can think of this as a 2 minus charge and think of this guy as a 1 plus charge here. So in this case here, we have different multimole ratio, right? So let's calculate. Again, we have to assume our 100 grams. So we want to calculate our moles, right? So moles is 100 grams divided by our molar mass of this guy. So it's 3 times 55.845 plus 4 times 15.999. Put that into your calculator. You get a value of 0.432. You get the multimole ratio. Again, this is per 1 of Fe3O4. So we're going to have to multiply this by 3 to get our iron, right? So let me shift this a little bit here. These two guys cancel out, so we're left with our moles of iron here, which is simply 1.295 or 1.30. All right, 1.296 here for rounding purposes. And then what we can do is, again, we can convert this back into our mass, right? So we have, again, mass is equal to moles times molar mass. So we have 1.296 moles times 55.845 grams per mole. This is going to equal 72.35 or 0.360. And then we can calculate our mass percent, right? So percent is going to equal the mass of our Fe divided by the mass of our Fe3O4, which is 72. Sorry, this isn't percent. This is in grams. 0.360 grams divided by 100 grams times 100%. This is going to give us a value of 72.36%. And this is our second one for this guy here. They wrote 72.4, so they rounded, which is also correct. So this Fe3O4 has a 72.36% mass of Fe. And then finally, what we can do is we can do the last one here. Very, very tedious, this question, but we almost got it. So we have Fe2O3. And again, this you can think of this as this decomposes to Fe plus either CO3 or CO2, but we don't really care about the carbonate here. And in this case here, we can see that this is a 1-to-1 ratio. So you don't have to worry about converting the mole ratio here. So again, we're assuming 100 grams of FeCO3. So we have moles is going to be mass over molar mass. So we have 100 grams divided by our molar mass of this guy. So it's going to be 55.845 plus the molar mass of carbon, which is 12.00011 plus 3 oxygen. So 3 times 15.999. Plug this all into your calculator. So that's 55. Yeah, this is a 55.845. My writings become messier. Plus 12.011 plus 3 times 15.999. This gives us a value of 0.8632. This is moles of FeCO3. And we said we already assumed that this is a 1-to-1 ratio, so we can also assume that this here is also 0.8632 moles of Fe. So we can convert that back to mass, right? So we have mass is going to equals moles times molar mass. And the molar mass is 55.845 grams per mole. This was a mole. Moles cancel out. Multiply those two numbers, you get 48.20 grams, and then of Fe. And then we get to figure our mass percent is equal to our mass of Fe divided by the mass of our FeCO3, which is 48.20 grams divided by 100 grams times 100%. And this is going to equal 48.20%. So that's going to be our answer for all three of those guys, which has the highest iron content. Well, again, highest content has the highest percent, which is 72.4. So, which means that magnetite has our highest iron percentage. So write this down. FeCO3 has a 48.20% mass of Fe. Therefore, Fe magnetite would have the highest mass percent composition of iron. So the solution is partially correct because they only figured out the first two. So I'm going to say incorrect just to help fix that up.